I'm back, and you guys should be able to hear me. No feedback. So we are looking at cylinder head here today, and this cylinder head is from a GM V8. Okay, it's from an all aluminum engine block and cylinder heads. It's also overhead valve, so it's a little bit different than our overhead cam engines, but the components are basically going to be the same. The only thing that we're missing in this is we're missing a camshaft. So we're going to take a look at all of the components in this cylinder head. And for this class in particular, I will be walking around to all of the different cylinder heads. You guys should be able to take a look and find all of your parts and the locations for all those parts in your individual cylinder heads. But for today, we're going to look at this one. It's a GM overhead valve cylinder head. So let's go. Now I know my face is not going to, this is me showing you guys this. So cylinder head, valve cover, got the gasket underneath, okay? And then once we look inside the cylinder head, we've got all of the, okay? So we've got valve cover, cylinder head. We're missing a couple of things over here, which we'll discuss. You can clearly see there's no yellow things out over here. So we're missing two of those yellow things, right? We're also missing two of these little funky things here that kind of go like that, all right? Besides the exhaust manifold. And the exhaust manifold is responsible for taking those exhaust gases and running them through our exhaust system and piping them out from the front of the car, all back of the vehicle and out and exiting the back, okay? Beside that, we've got our ignition system here. All right, so we've got our spark plugs, okay? Sorry, we've got our coils, okay? And we've got our spark plug wires that lead down to the spark plugs. Spark plugs are located on the cylinder head right here, right? So ignition coils, spark plug wire, and then the spark plugs, all right? And these spark plug wires obviously are attached to the spark plugs like that, all right? So you've got your ignition coil, you've got your spark plug wire, and that leads to your spark plug. So we're going to take it off. So I want to concentrate on the cylinder head for now. Okay. Got here. In our cylinder head, we've got a bunch of holes. Got a hole here. So we got 4 holes. Those all represent ports. What side port it is, whether it's the intake or exhaust port, I'm not sure, but I'll show you guys how to decipher which port it is by looking at what's inside the combustion chamber. Okay, so 1, 4 ports here. On this side, we've got 1, 2, 3, 4 ports also. Again, I don't know whether it's intake or exhaust, but when we flip this head over, we'll be able to look at the valve, the 2 valves that we've got inside the combustion chamber for this engine, and we'll be able to decipher whether this hole is the intake port or it's the exhaust port, all right? So let's just flip it over real quick. Let's take a look. So flip this head over. We've got valves. If you guys are looking at this and you can count, you can see that for each cylinder, we've got 2 valves per cylinder. So we've got 1, 2, 1, 2, 1, 2. One of the things that's in class is if you've got an equal number of valves per cylinder, when you're looking at the valves, if it's an equal number of valves per cylinder, then the intake valve is generally bigger. So the head of the intake valve is generally bigger. And the reason being is we want to be able to suck in more air than we can force out. The more air we can run, the more fuel we can add, the more air and fuel within our cylinder and the combustion chamber creates a bigger, badder explosion. And in turn, we produce more power. So one, valve two. Let's take a look at these components now, okay? Here we've got a valve, and here we've got another valve. You can clearly see that one valve is physically bigger than the other as far as the size of the head, okay? So this one must be our intake valve, and this one must be our exhaust valve because we've got two valves per cylinder. Now, if we had the intake valve might be slightly smaller than the exhaust valves because there would be more of them. So there'd be two intake valves and one exhaust valve. So with an odd number of valves per cylinder, sometimes, but usually, the intake valve is generally physically smaller than the exhaust valves because there's more of them. All right. Intake valve. Go. Exhaust valve. Go. So how do we determine which port is the intake port and the exhaust port? Very simple. So we're just gonna pull our valves out, and then all we need to do is take our finger if you want, okay? And let's see where that leads, all right? So what I'm doing is I'm physically putting my hand into the hole, and then I wanna see where it leads. So on this particular engine here, this is the exhaust. This is the back of the exhaust valve. So this is leading to the exhaust port. If I take my finger, better yet, if I take this toothbrush, okay, you can clearly see that the toothbrush is now coming out, okay, through the hole that is representative of the exhaust port on this particular cylinder head. So on this particular cylinder head, this is my exhaust port right here, all right, which is a little bit smaller. And then if I was to flip this around, okay, not sure if you'd be able to see it. Let's see if you can. Okay, there is my intake port because again, if I take this toothbrush and I put it through where the intake valve goes, I push it through, there it is there, all right? So this is my intake port. So my intake port leads to the intake valve, and that allows the air to enter the combustion chamber. The exhaust valve leads to the exhaust port, and that port allows the exhaust gases to leave or exit the combustion chamber. Got these things, okay? These are called the valve springs. And the purpose of the valve spring is to close the valve. That's the only purpose of the valve spring, is to close the valve. On top of the valve, we've got the retainer. And the purpose of the retainer is to retain the valve onto the spring. So the purpose of this retainer is to center the valve on the spring, and then through the use of locks or keepers, we keep that valve, or we lock that valve in position in the center of this spring. So valve spring, valve spring retainer. Inside the retainer, we've got the keepers, or the locks. So you guys put the little locks just like I instructed. Put them into the little container here. And that's where we're going to get got 4 of them. Now, I'll show you guys the electrode video, which you'll be able to look at and really differentiate how these things go in. My retainer, if we're looking at the retainer is kind of shaped like this, okay? So when we're looking inside the retainer, it has this bevel, okay? And that bevel is meant to accommodate our locks. And the locks are quite small. There's the locks right there. And the locks are shaped also with beveled shape. And once we put these things all together, as long as we put the keepers keepers or the locks in properly, everything will match. So once we put these locks in, and the locks have small pointer, the locks have a little notch here. Not sure if you can see it. I'm trying to see it. There you go. Okay, there's a little notch there. And then in the actual valve, there's a little groove, right? So there's a groove, and then there's kind of like, not really a notch, don't call it, but it's something that's kind of like, it's on the keeper or the lock, and it's got this little area here that's raised. And what they do is they match the groove. They match the groove on our valve. Okay, so that little keeper will lock itself into that groove. Okay, and when you put them together properly, they'll kind of look something like this, and they will allow our retainer to stay onto the spring. And once we allow our retainer to stay onto the spring, the valve is now securely centered on the spring. Let me show you how these work. I'm going to ask you guys to do this when you are being tested. I'm going to say, okay, put your springs and your retainers and your locks together. And all you guys have to do is slip the spring over this valve, put the retainer on, and then as long as you set everything up properly with your keepers or your locks, okay? And once you've got your locks looking like this, so when you're looking at it, you can see that taper or that bevel, right? So when you're looking at the bottom, it's much smaller than the top. And as long as you've got it in properly with the small side on the bottom and the large side on the top, this lock assembly will fit into our retainer. And once you've got it all set up properly, it fits like a glove, okay? And those two locks that are inside this retainer, they will hold that spring onto the valve. Very simple mechanism. And as long as the spring doesn't get damaged, nothing will happen to this, because the spring, the natural inclination of the spring is to stay in its resting position, which is like this, it's extended, all right? And as long as that spring is intact and it's not worn and it keeps pressure on that retainer, those locks will not fall out, okay? So we've got valve spring, valve retainer. Inside here, we've got two locks, keepers, okay? And they're responsible for keeping the retainer attached to the spring. So for those of you that have taken your springs out, and I think most of you have, as long as you put your keepers or locks in a specific spot, you won't lose them and you're okay. Let's take a look at the rest of the cylinder head. So again, spring, retainer, two locks or keepers, and obviously our valve, okay? Intake valve is the one colored red, exhaust valve is the one colored white. And you can see the difference in size because we've got an equal number of valves per cylinder, which is 2, and the intake has to be bigger. Okay, what else do you need to know on, on your cylinder? Obviously, you know that this is the spark plug, okay? So the spark plug is right here, okay? That's the, that is the component that creates the spark in a gasoline-powered engine, and that spark is what ignites the air-fuel mixture and creates the power stroke. Here on the cylinder head, I wish I could come in a little bit closer. This area here on our cylinder head, okay, that's called the valve seat, all right? So the purpose of the valve seat is to sit the valve, okay? So the valve head sits on the seat. So when we put the valve in, boy, these valves are, I'm gonna have to get some lube because there's a small amount of clearance. So right now I've got a valve. Don't want to go past the guide too far. Just gonna add a little bit of lube to it. It still doesn't want to go on. I guess there's a difference in temperature between the cylinder head and the valve, and and then that's going to go back into a car. Right now, that's just too tight, and I'm not sure why it's too tight. Go. Okay, so there's my valve, and the valve sits on the valve seat. So right here in the cylinder head, we've got the valve seat. Okay, and the purpose of the valve seat is for the valve to sit on it. Okay. Inside here, if you could notice this small round area here, that's where the stem of the valve slides up and down. And that little part there is called the valve guide. So the valve guide sits, it's pressed into the cylinder head. What is it? It guides the stem of the valve. It allows that valve to move up and down squarely within this seat. All right. So the guide guides the valve stem. That's it right there. Okay. So I know I'm not zooming in too much, but you can see that little circle right there, that little small area there. And that's where the valve gets pushed in. Okay. This head up a little bit to make the stem expand because the clearances are so tight. We also look at style or shape of the combustion chamber. And when we're looking at this, and I know I explained this in class, I said most engines are going to have what's called a hemispherical combustion chamber. But with a hemispherical combustion chamber, the spark plug has to be situated right in the middle of it. So a hemisphere is basically half of a sphere, so half of a ball. So it would kind of look like this, be shaped round. And my spark plug would have to be situated right in the middle of it. So it would have to extend from the middle of my sphere, my hemisphere. If you're looking at this, you can see that the spark plug is set over to one side. And because it's set over to one side, we've got a much smaller area here and a much larger area here. Because what we're trying to do is we're trying to create an explosion where the explosion starts here. And when the explosion starts at the spark plug, it propagates or it expands across my combustion chamber, distributing the power and the explosion evenly onto the top of the piston that's going to be forced back down, right? So this cylinder head, it's not a hemispherical design. It's either a bathtub or a wedge, and I'm not really going to disclose what that is because this is someone's engine, and you guys are going to have to figure out what this is, all right? But it's definitely not a hemispherical design because the spark plug would have to be in the middle, okay? So what have we figured out? The type of combustion chamber. I haven't told you what this is, but it's not hemispherical. Spark plug, we know what that is. Valve seat, we know what that does. Again, if we're looking in here, there's the valve guides. Okay, there's the intake valve guide and there's the exhaust valve guide. Okay, we've discovered which port is which. And what did I do? I took toothbrush, something that I've got here that I can point, and I pushed it through here, and you can see it coming through this hole here for the intake valve. So this is my intake port right here. On the opposite side of the cylinder head, we've got the exhaust port, because again, if I shove it through here, it comes through where the exhaust valve is, and that's my exhaust port. Exhaust port. Combustion chamber, you need to know the design, spark plug, guide, okay, seat, intake valve goes here. Now, what do we have? We've got a few things missing because valves are out, springs are out, my retainers are out, and my keepers are out, along with these things. So you've got these things right here. Here's one right here. And you can see the shape of it. Okay. So Patrick, this is your rocker. All right. And it's the job of the rocker to transfer the linear motion from the crankshaft. And that linear motion is going to be transferred over to the valve. So this rocker, as it's moving up and down, it's transferring the linear motion of the camshaft lobes to the spring. And that in turn opens the valve. So what I told you guys earlier is the camshaft is responsible for the timing of the opening of the valves, but it's not responsible for closing the valves. The only thing that's responsible for closing the valves is the valve spring. Spring is responsible for closing the valve. The rocker transfers the linear motion of the camshaft, that motion there, because you're going to have a push rod that's pushing up and down on it, okay? And it takes that linear motion and it transfers it to our valve, and that allows the valve to open, okay? The next thing that we've got in here, let me see if I can bring my camera down a little bit, because I'm going to use this for my, use this video for my YouTube channel. Let's see what we can do here. There we go. Get a little bit closer. Hopefully the camera doesn't fall over. Here we've got these two pieces right here. Now we're not pulling them off of the engine, but we have to recognize what these are. So these two pieces here, we've got one for the intake and we've got one for the exhaust, okay? And these two parts right here, we call those the valve stem oil seal. And those valve stem oil seal, what they do is they prevent oil that's in this area, because you need all the oil in here to lubricate all of these moving parts. Those valve stem oil seals, they will seal the oil that's in here, going down the stem of the valve and getting into the combustion chamber. So the purpose of the valve stem oil seal is to seal the oil that's within the cylinder head here and prevent the oil from going down, running down the stem of the valve, and ultimately dripping into the combustion chamber. Because we've got any oil running down the valve stem and dripping into the combustion chamber, we're going to have an oil burning situation with our engine. And when we start to burn oil in the engine, it's not very good. Okay, so those valve stem oil seals, all right, they prevent oil from running down the valve stem and dripping into the combustion chamber. Valve stem oil seals. Now, if we can get a little bit closer, I want to show you guys. Let's see if I can get a little closer. The light's not very good. I think this is going to fall over. Yeah, this is going to fall over. Let's see what I can do here. This angle is a little bit too tight. Okay, so a little bit closer. That's better. There we go. Okay. Now, our cylinder head, it's made out of aluminum. And because it's made out of aluminum, You can't have the valve spring, which is made out of steel, very hard steel at that, okay, pressing on the aluminum, because with the motion of this valve spring going up and down, constantly on top of the aluminum, it would wear the aluminum out. So what they do is they insert a little valve spring seat made out of metal. Like it. So maybe you could, maybe this is a little better. Let's take a look. Okay, so with this light on here, you can see the difference in the color. So when we're looking at this, you can see that the aluminum is a little bit shinier, and then this area here is a little bit darker. What have they done? They've inserted a metal, kind of like a little collar or sleeve, and that is the valve spring seat. It has to be made out of metal because the cylinder head is made out of aluminum, and we don't want that steel valve spring constantly wearing away at the aluminum. So valve stem oil seal, and then immediately below it, you've got a replaceable valve spring seat. What's the purpose of the valve spring seat? Exactly like the valve seat on the other side of the cylinder head. That's where the valve sits on. So the valve spring seat is where the valve sits on. Okay, so you've got a valve spring seat on this side of the cylinder head. On the opposite side of the cylinder head, you've got a valve seat where the head of the valve sits on. This is the valve spring seat. The spring sits on the seat. What else do you need to know? What you're going to need to know, and I'm going to show you guys this. We're going to run through the cylinder head tutorial that I've got from the textbook, which we're not working from this year. What you've got to be able to do is you've got to determine what type of valve seal this is. So this valve stem oil seal, there's a couple. And what I'll do is I'll probably show you tomorrow. I'll show you some, I'm going to probably show you about 3 or 4 different types of valve stem oil seals, all right? And you'll be able to determine which type it is just by simply looking at it, okay? This particular seal here, it's the newest type of valve stem oil seal, all right? It's made out of a soft rubber, and it's got a spring here, and that spring is actually responsible for squeezing the rubber, okay, so that it forms a nice tight seal on the stem of the valve, all right? So we've got a seal right here. We've got a seal with a spring on it, and it squeezes that stem seal tightly onto here. And what that does is it has a positive effect on the stem, and that positive type valve stem oil seal, it really prevents no oil from running down the stem of the valve and ultimately dripping into the combustion chamber, okay? So I think we've covered all. Let's take a look. The rocker. The rocker converts the linear motion of the camshaft flow, okay, and transfers it from this side to this side, and it ultimately pushes on the valve spring, and it causes the valve to open. When we compress the valve and spring, the valve will open. Here we've got the valve stem oil seal, and we've got the valve spring seat. And this one is made out of metal because we've got an aluminum cylinder head. Here we've got the valves. We've got 2 valves. And when you guys are looking at the valves, because you know that the intake valve is generally bigger, if it's an even number of valves per cylinder, we know that this is the intake valve and this is the exhaust valve. Over here, we follow down. got the intake port here, because that leads to the intake valve. On the opposite side, we've got the exhaust port that leads to the exhaust side. And flip this over. We've got the valve seat here for the exhaust. We've got the valve seat here for the intake. Inside in the center of this, we've got our two valve guides. Okay. Got our spark plug, got our combustion chamber, and then we've got, well, again, one of the things that you need to do is you've got to be able to tell me what type of combustion chamber design it is. All right. Quick hint, I've given you guys a handout, and the three main types of combustion chamber designs. There's many multiple of those three general types. Okay. But the three general types that we usually discuss are a bathtub and a wedge. And you guys will have to be able to look at this and figure out what it is by looking at the handout. Okay. So I think we've just covered the cylinder head. I don't think there's anything else for me to cover. No, I showed you guys the spring. I showed you guys the valve spring retainer. I showed you guys how it all kind of fits together. I showed you guys the keepers or the locks. I showed you how the locks go on. I showed you the shape of the locks or the keepers. And once you've set it up properly, all right, it's going to look like that. And that will never ever let go unless there's a problem with the valve spring. So if the valve spring was to break or to collapse or to become incredibly weak, all right, this might have the opportunity to maybe possibly pop out and drop these keepers out. And if we did that, then this entire assembly would just kind of disassemble from itself. Okay. Any questions? No, you guys don't want to participate now that I'm recording this? No questions from you guys? Okay, so there we go. That is Group 3's cylinder head from the GM engine, overhead valve. This tutorial on this particular cylinder head is done. Just kind of there's the whole thing right there. One man show, guys. So this is how it goes. So there's the cylinder head right there. And the first thing that I did was I just kind of showed you the valve cover, right? Which goes over and seals it all up. That's the tight. I also showed you guys. And for Group 3, you guys are putting all of this stuff. I just don't want any of it to get lost. So I'm actually going to put everything here. I like what you guys did. Put it all together, you put the valves together with the springs. I'm okay with that. But I put everything back together with this container here. Nothing's going to get lost. Okay. I also showed you guys the exhaust manifold. I showed you guys the ignition coils. Ignition coils. I showed you the spark plug wires, okay, which attach to the spark plugs. And I showed you the exhaust manifold. So exhaust manifold. And the ignition coils and the spark plug wires that lead to the spark plugs. Okay, I'm going to pause this recording, but I've got to go over to my other computer, so give me a minute.